On this DeBacco University video, I'm going to show you how oxidation changes across a period on the periodic table, as well going over some of its properties and how it influences bonding of different elements. Now the reason I have this picture here, this rusting, this is an example of kind of the oxidation process. Now oxidation has an opposite called reduction, but oxidation itself is when an atom loses one or more electrons. The contrast to that would be reduction. An atom gains one or more electrons. So if one atom is losing electrons, another atom has to be gaining it. Way to remember this is the term oil rig, or Leo says Gur. Oil rig stands for oxidation is loss of electrons. Rig stands for reduction is gain of electrons. And Leo is losing electrons, oxidation. Gaining electrons, reduction is Gur. Whatever one of these tries to help you, because remember, matter can't be created or destroyed, only transferred here. So looking at the valence electron trend, valence electrons increase from 1 to 8 as you move from left to right on the periodic table. The maximum oxidation state generally increases across the period, peaking around group 15 or 16, and then a little drop there for the noble gases. Again, those valence electrons are those electrons on the outermost shell of the atom. Metals and nonmetals. Metals on the left tend to lose electrons and form positive oxidation states, as we can see here. Nonmetals on the right, they tend to gain electrons or form negative oxidation states. And you may have heard the term cation. That would explain the positives. Anion would describe the negatives here. Now, what's that influence on bonding? Well, the metallic character fades, less tendency to lose electrons. As it non-metallic character rises, it's a greater tendency to gain electrons. This shift changes how elements bond with oxygen, influencing the oxidation states and the oxidative behavior. Again, that oxidation is occurring when that water and oxygen are reacting in the environment with a metal, causing that essentially that rusting to form. Key part here is we're looking at that gaining or losing electrons like we would see with ionic bonding. Hopefully it gives you just a little bit of an idea of where these ions and oxidation states exist on the periodic table. If you can know and memorize them connected with what family they are, that'll really help you understand what the periodic table organization can really show you when it comes to working with different atoms and elements.